All right, today we're going to talk about a totally new way for AI to think. We're moving away from these simple, straight lines of logic to something that looks a lot more like a living web. A web of reasoning that can actually learn, adapt, and maybe even reflect on its own thoughts.
So let's just dive right in. The biggest problem facing modern AI is something called a structural mismatch. You see, an AI stores its knowledge as this incredibly rich, complex web of interconnected facts. But when we ask it to reason, it has to force all of that complexity through this tiny, narrow, linear funnel. Just a simple chain of thought. Think of it like this, right? The AI's brain is like a giant, detailed map of a city. But its reasoning process is like getting directions one single turn at a time. All that amazing context, the alternate routes, the view of the whole city, it just gets lost. Okay, so how do we fix this? Well, the very first ingredient is to let the AI think in that same web-like structure. We need to make the way it reasons match the actual shape of its knowledge. And that brings us to something called self-graph reasoning, or SGR for short. And this is a huge leap. Instead of just following a path someone else drew, the AI learns to build its own logical structure as it thinks. It stops being just a map reader and becomes a map maker. I mean, this slide just shows the difference perfectly. On the left, you've got the old way, this fragile little chain where if one link breaks, the whole argument just falls apart. But on the right, you have SGR, a strong, robust web of logic, where the AI can explore multiple ideas at the same time and even check them against each other. And get this isn't just some cool theory. When they actually trained models with this web-like thinking, they saw a performance jump of over 17% on some of the toughest reasoning tests out there. So yeah, thinking in webs makes AI a whole lot smarter. So let's get to the second key ingredient, because this is where it starts to build. It's not quite enough to just think in a web. We also have to give the AI the ability to process information at different speeds, kind of like our own brains do. This is all based on something called the Universal Signal Decomposition Framework. The main idea here is that any piece of information, like this picture, can be broken down into different frequencies. The low frequencies, they capture the big picture, that's the forest. The mid frequencies define the objects, the trees. And the high frequencies, they handle all the tiny details, the leaves. And here is the crucial point. This is a universal principle. The exact same framework can be used for language to tell the difference between a document's main topic and its individual word choices, or in finance to separate out huge market trends from tiny daily fluctuations. It's a fundamental way of seeing information at every possible scale. We can actually map these frequencies to different speeds of thought, taking inspiration from brainwaves. So you have slow alpha wave thinking for big, long-term strategy. Then medium beta wave thinking for tactics and context. And finally, super fast gamma wave thinking for dealing with immediate details and actions. And now for the real aha moment. We take the AI's ability to build these webs of logic, and we combine it with its new ability to think at all these different speeds. This is where everything really comes together. This combination creates the frequency-governed self-graph reasoning architecture, or FGSGR. It's this unified system where the different speeds of thought, which this side calls the substrate, are actually in charge of how the web of logic, the engine, gets built and refined. And this whole thing runs on 4 key principles. It makes sure knowledge and reasoning are speaking the same language, that fast tactical moves don't mess up the long-term strategy, that safety policies are built right into the thinking process, and, maybe most importantly, that the AI learns to build these structures all by itself. This slide shows you how it all works in the real world. You've got different tasks being assigned to the right frequency. That fast gamma band is handling little fact checks in milliseconds, while the slow alpha band is taking care of huge strategic changes over the course of minutes. But wait, there's one final, absolutely crucial piece missing. For an AI to truly learn, it can't just think. It needs a way to reflect on its own reasoning and then use that reflection to make its internal knowledge map better. It needs a feedback loop. Before, the flow of information was basically a one-way street. The AI's knowledge would inform its reasoning, and that's it. End of story. But what we actually need is a dynamic two-way conversation, where the act of reasoning itself goes back and refines the very knowledge it came from. And we get that with something called AI backchanneling. This is the key that unlocks a truly adaptive system, because it creates that feedback loop. It lets the AI's reasoning process improve the very knowledge structures that it's built on top of. The core idea here is just beautiful. The system sends a reasoning signal forward and a feedback signal backward. And when those signals resonate, when they reinforce each other instead of clashing, that's a sign that the AI's reasoning is on the right track. It's coherent. It's like hitting a perfect chord on a guitar. And this feedback is happening across all three frequencies. The fast back channel is making these rapid-fire adjustments. The medium channel is refining the context. And the slow channel, well, that's updating the AI's core long-term strategies and beliefs. It's literally learning at every single time scale.
So what does all this mean when you finally put it all together? With FGSGR and this back-channeling, we now have an AI that can go way beyond simple problem-solving to something much more profound.
When you compare FGSGR to the older methods, its advantage is just crystal clear. Linear models can only go in a straight line, but FGSGR can handle complex stuff, like synthesizing parallel ideas or, and this is crucial, using cyclic refinement to actually loop back and improve an earlier thought. That was simply impossible before. And this brings us to one last really provocative thought. We've created a system where the knowledge graph doesn't just inform the reasoning anymore. Now, the act of reasoning itself continuously goes back and sculpts the knowledge graph. This is an AI that isn't just using its mind, it's actively and constantly rebuilding it. And that, well, that changes everything.